70-742, Lesson 11, Installing and Configuring Active Directory Certificate Services. You say, hey, we've done this a number of times. We've set up a certificate authority, what, 3, 4, 5 different times now. We know what that is. Well, we've only touched the surface of what we do with certificates. First and foremost, understand that the concept of PKI, that's public key infrastructure, is based on asymmetrical encryption. What is asymmetrical encryption? Well, symmetrical, if something's symmetrical, it's a mirror, right? Symmetrical means that 1 equals 1. If we do symmetrical encryption, we use a single encryption key to encrypt data, and the same key that encrypts the data decrypts the data. Asymmetrical encryption is the concept of the public-private key. There is one key to encrypt, there's a separate key to decrypt. So I want to take a little bit deeper look at that before we move on. And this goes over to one of my PDFs that I present in cybersecurity. So understand that asymmetrical cryptography, we also call it public key cryptography, and it's the basis of public key infrastructure, PKI, which is what we use all day long when we're on the internet. It uses a symmetrical cryptographic algorithm. Keep in mind that symmetrical might be faster, but asymmetrical is much more versatile. If we were to attempt to secure our websites using symmetrical encryption, every single connection would have to have a separate key. So in other words, if there were 2 users of your website, you would have to hold 2 encryption keys, and each one of those 2 users would each have their own decryption key. This would be how you would encrypt their communication to keep it secure. Now, if there's 10 people accessing this website, each one of those has to have their own separate encryption key. And you have to have a copy of that same key. So now you have to manage 10 keys. What if there's 1,000 or 10,000 or 100,000 users? That would mean that you, as the website owner, would have to manage 10,000 encryption keys. Virtually impossible. Well, it is impossible. This is where asymmetrical encryption comes in. There is a private key and there is a public key. The public and the private key are related, but they can't be used to reverse engineer each other. The private key gets generated first, and it in turn is then used to generate what we call the public key. It's a one-way function. So the private key can generate the public key, but the public key cannot generate the private key. It's impossible. It's mathematically impossible. You can't figure out what the private key is with the public key. So we secure our website with the private key, which has a mathematical relationship to the public key. So anybody that holds the public key is able to verify that yes, this website is the only website possible to have that private key. 100 million people can each have a copy of the public key, but there's only ever one private key. This is asymmetrical encryption. One private, as many public keys that are related to that as necessary. In terms of email, we can use the same asymmetrical encryption to secure our email. If a user encrypts their email with a private key and freely distributes the public key, anybody who is the recipient of their encrypted email that holds that public key can decrypt the email. Anybody who wants to send them an email and know that only that recipient would be able to decrypt it would encrypt it with their public key, knowing that, here again, only the person who holds the private key could decrypt the email. This way you can ensure that only the intended recipient can decrypt the email. So in one case, anybody would be able to view your email if they hold your public key. In the opposite case, only that person that holds the private key could decrypt an email sent to them. This is the concepts of privacy. And here are some examples of that. Anybody that's interested, I can forward on this document to you. And here it explains how hashing is used with that to verify integrity. Okay, let's get back to our lesson. That gives you a basic understanding of how asymmetrical encryption works. We've installed a certificate authority as an enterprise CA. You can also install as a standalone. Understand that our certificate services role allows us to issue and manage digital certificates as part of PKI, Public Key Infrastructure. It's a system that combines hardware, software, policies, and procedures to create, to manage, to distribute, to use, to store, and to revoke digital certificates. We have CAs, certificate authorities. We have RAs, registration authorities, and the registration authorities verify and authenticate the validity of each part of your CA. Each entity that is involved in an electronic transaction that uses that public key cryptography. The certificate authority binds a public key with respective user identities and issues digital certificates containing the public key. Now, I just briefly did discuss what asymmetrical encryption is, so I'm not going to go over that again. But what are the benefits of public key infrastructure? Well, confidentiality. It allows you to encrypt data that can be either stored or transmitted. It provides integrity. Using a digital certificate identifies whether the data has been modified while the data was transmitted. And finally, authenticity. By using a message digest or hash that is digitally signed using the sender's private key. Because that digest can be decrypted only with the corresponding public key, it proves that the message could come only from the sending user. That's the concept of non-repudiation, not being able to deny that you were the sender. Typically, you're going to install the CA role on more than one server. You're going to create an infrastructure of CAs. That first one that we create, and in our case, in our lab environment, our only CA, is also known as the root CA. It's what establishes our PKI in the network, and it's the very top level point in our entire structure. Each role that we install is responsible for a specific portion of that infrastructure, and it comes together to form a complete solution. So we know what the CA is, right? Certificate authority, and it's the component that issues certificates to users, computers, services, and it manages validity. We can install the CA web enrollment, and this is a component and it provides a method to issue and renew certificates for users, computers, and devices that are not part of your domain. They're not connected directly to the network or are for users of non-Windows operating systems. We can install the online responder role, and this is a component that manages the OCSP, the Online Certificate Status Protocol, and this is a role that validates and revokes certificates. We can do the Network Device Enrollment Service. Here again, it's a component that can be used to assign certificates to routers, switches, and other network devices. Just as it says, Network Device Enrollment Service. We can do the Certificate Enrollment Web Service. It's a component that allows computers to connect to a CA using a web browser to request, renew, and install issued certificates. Get a copy of the Certificate Revocation List, the CRL. download a root certificate, or enroll over the internet or across forests. And we can do the Certificate Authority Policy web service. It's a component that enables users to obtain certificate enrollment policy information. When we installed that first CA, we had a choice of either doing a standalone CA or an enterprise. We did enterprise because we were in a domain. A standalone CA works without Active Directory. It doesn't need Active Directory, but understand that that server can be a member of your domain. Doesn't have to be, but it can be. An enterprise CA requires Active Directory, and we typically use it to issue certificates to users, computers, devices, servers for the organization. Here again, your users can request certificates using manual enrollment, web enrollment, or auto enrollment. We can create group policies to automatically distribute our certificates. Okay, so the very top level of our hierarchy is our root CA. Keep in mind that when we created that enterprise root CA, it was created for our domain, and it was trusted by all the domain systems and users. We should then create subordinate CAs. Most larger organizations are going to have multiple CAs, and that root CA is going to be taken offline once it's been created and the hierarchy is working. The number of subordinate CAs is typically determined by geographic location or the number of clients. Keep in mind that if a CA is compromised, all certificates issued by the CA and any subordinate CAs that are under the compromised CA are also considered compromised. This is why we typically take the root CA offline. This is to maximize the security. This leaves the subordinate CAs to issue certificates. So if a subordinate CA gets compromised, you only have to revoke those certificates that that particular CA issued. So we've done the install the Active Directory Certificates server role a number of times, setting it up as an enterprise CA. But what we have not done is we've not installed a subordinate certificate server. So let's take a look at that process, and I'm going to do that in the context of our lab. And while you will not be performing the lab because we're not in our Hyper-V environment, I wanted you to see this. Okay, so as you can see, my DC1 is running. I'm going to go ahead and I'm going to access SVR1. And here that comes. We'll go ahead and we'll get logged in. So everything else should be running. I've got our router running as well. Let me just double check, make sure that my yep, everything's good as far as network switch. So what we're going to do is we're going to go up, we're going to go manage, and we're going to add roles and features. We're going to go next, next, and next. And we're going to install the Active Directory Certificate Services role. We're going to add features. And I'm going to then click next, 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 and we're only selecting the certificate authority. We're going to click next, we're going to do install. I'm going to pause the video while it installs, but it shouldn't take very long. Okay, well, I actually only had to pause it for about 20 seconds. Now what we're going to do is click Configure Active Directory Certificate Services, and we're going to use the Adatum Administrator account. I'm going to click Next. On the role to configure, I'm going to select Certificate Authority, click Next. Here again, it will be an enterprise, so we're going to say Next, and it knows that there's already a root. We're going to do subordinate, CA. We're going to create a new private key. So the root has its own private key that it created. This one will have its own private key. That's why you're able to only have to revoke certificates for this subordinate if certificates get compromised, if the keys get compromised. If we have three different subordinate CAs, they each hold their own private key. Okay? All right. So we go next. We're going to change the, I'm going to change the key length. I'm going to change it. I'm going to make it more secure. 4096 bits, all virtually unbreakable. 2048's just about there. Next, keep in mind, let's go back to that for a second. Why is this stronger than 2048? Why is it stronger than 1024 or 512? It's all about computing power. As computers get more and more powerful, a key length that was once secure forever can be broken in time. Faster and faster computers make older encryption algorithms less secure. It's all about computing power. 4096. We go next. On the CA name, we're going to leave it be the same. We're going to click Next. Now we're going to send a certificate request to the parent CA. So we want to select Send a Certificate Request to the parent CA. And that parent CA we're going to select is right here. Click OK. And then we click Next. Now we can accept the default location and we click Configure. So it's retrieving from the parent and being configured to be a subordinate CA. And there it is, it's done. And just that simply, we have created a subordinate CA. If we wanted to, we could take the root CA offline. Let's move back over to our lesson. Now understand that by default, your CA certificate is only good for a maximum of 5 years. And when you deploy certificates, you can't deploy certificates that are good for longer than the validity period of that CA server. So the longest you could issue a certificate for is 5 years if you issued them on the same day that you created your CA. However, you can renew your CA. So what we can do is just what you see on your screen. You go to Tools, Certificate Authority, and you right-click on the CA server, and you go All Tasks and Renew CA Certificate. Let's take a quick look at that. If I come down and I go to Tools and Certificate Authority, and I right-click on the name and go Alt, I can renew the CA. Okay, it says do you want to stop it? You can't be running it during the operation. So you say yes. Stops it. It says, hey, you need a new certificate for your CA when the lifetime of the certificates you are currently issuing is reduced. So for example, if you issue certificates that are good for 1 year, you need to do this before your CA certificate is less than 1 year left in its validity. You need a new signing key when signing key has been compromised. You might require a new signing key to be used with a new CA certificate, if you have a new program. Or the current revocation list is too long. You say, hey, do you want to generate a new public and private key? We'll say yes. It says, who's the online CA to make the request to? Well, we are subordinate CA. We request it from our root CA, which is our DC1. We click OK. Did the renew, and now it's going to restart. And there we are. We can go to Properties, and here we can see a new certificate has been issued. There we see the certificate. Okay, back to our lesson. Okay, so that's that. We can export certificates. For example, if we want to export our CA certificate, we can go back into that same view. We right-click the CA, we choose Properties, we view the certificate. Well, let's do that. What I do is I right click, I go to Properties, and then I click View Certificate. And now it's going to pull that certificate up. It's going to take just a few moments. And there's that certificate. Now, I only set it for a 2-year length, but we can go Details, and we can copy the file. We can go Certificate Path, and we can view the path of our, what is that hierarchy. We can view the certificate from the root. And there's our root CA. Okay, so let's go back here. Okay, so what we do is we click View Certificate, then we click Details, we say Copy to File, and here we are at the Export Wizard. We would simply click Next. We would select the format. We can use the .cer. Click Next, and we're going to call it LUN SVR1 sub CA cert. And where are we going to export that to? Let's take a look. It's going to be exported into our Documents folder. Next and finish, and just that quickly the certificate's been exported. We can publish our root CA certificate through group policies. So let's see how we do that. I'm going to go onto the LUN-DC1. We can publish our root certificate through group policies. So I'm going to go ahead and do that. And in this way, it's published through our domain group policy. Group policy management. We're going to expand a datum. Now, in the illustration that they show you doing it in the default domain policy. I'm going to create a separate policy. I'm going to say create a group policy and link it here, and I'm going to call it domain root CA certificate. So there is my policy. But first, what I've got to do is I've got to export my certificate. So I'm going to go to Certification Authority. I'm going to select my datum. I'm going to go right click, go to Properties. We're going to view the certificate. We're going to click Details. We're going to copy the file. Next, next. I'm going to call it a datum root CA cert. Next, next, export. Okay, done. It should be in my Documents folder. I exported that CA root certificate to my Documents. I want to move it and place it somewhere where it's available for all of our computers. Well, where? I can do it in my Software folder. So I'm going to go in here. I'm going to go to Documents. I'm going to copy it. I'm going to open up that Software folder, which is shared, and paste. So now I can distribute that from there because it's a share that's accessible through the network. We go back to our group policy management. I'm going to right click and edit, and we're going to go into our group policy editor. Under Computer Configuration, expand Policies, and then Windows Settings, and then Security Settings, and you'll see right here is Public Key Policies. I'm going to right click on Trusted Root Certification Authorities, and I'm going to select Import. We're going to say Next, and the file name that I'm going to import is //lun-dc1. Oh, too many backslashes there. Let's get rid of that. And we go Software. In fact, what I'm going to do is I'm going to copy that path. I'm going to click Browse, and I'm going to put the path in here. Oh, I can see it right here. I'm going to click on that. I'm going to select it. There is our path. We click Next. We're going to place all certificates in our Trusted Root Certification Authority store. Next, and Finish. And the import is successful. It's linked to our domain. It's now available for all systems. That's how you publish a certificate through group policy. So we created a group policy to automatically add our root CA to our list of trusted root certification authorities. Let's see if that occurred. If I run a resultant set of policy to take a look at the group policies that are being applied to our domain controller, I can right click on Computer Configuration, go to Properties, and I can see right there Domain Root CA Certificate. And if we drill into our settings, we can see there's public key policies, and there's our certificate for our Trusted Root certificate authorities. So let's see that in here. Let's go to an MMC, and I added the local computer certificates, and right here we can see server authentication listed under Trusted Root Certification Authorities. It's just that easy. Okay, back to the lesson. Let's take a look at what a CRL is. What happens if someone loses their house key? Well, we probably need to change the locks on the door in case someone who has the stolen house key and knows whose key it is. Who knows? They could enter your house in the middle of the night and rob your house, right? Okay, so the same way with certificates, if a CA improperly issued a certificate, or if a private key had gotten compromised, we would want to revoke that certificate, so the keys would no longer be valid. Additionally, after a set period of time, certificates expire. How do our clients know if those certificates are valid or not? We do it through what's called a Certificate Revocation List, a CRL. It's a digitally signed list issued by a CA, and it contains a list of certificates that were issued by that CA and that have been revoked. Let's take a look at how we change the settings for our Certificate Revocation List distribution. It's as simple as going to your certification authority, expanding your server name, right-clicking on Revoke Certificates, and going to Properties. You can then determine how often that revocation list gets published. We can also specify how often what's called a Delta CRL gets published. What's a Delta CRL? A Delta CRL contains only the certificates that have been revoked since the last regular CRL was published. If we publish our CRL once a day and we're in a very, very large environment, there may be a number of certificates that expire before the next one gets published. The Delta CRL keeps that list up to date so that you don't have to completely rebuild that whole CRL on an hourly basis. You can do it with the much smaller Delta CRLs, and here's where you can see that. If we go into our certificate authority and right click on revoked certificates, under properties is where we see that. And right here's your publishing parameters. By default, out of the box, it's 1 week, and the Delta CRLs are 1 day. Now that may be fine for a small organization, but perhaps for a larger organization, they need to bring this down to the hours and days period. Okay, we can cancel out of that. Now, what is the online certificate status protocol? It allows the recipient of a certificate to submit a status request using HTTP. And it is installed when we install the online responder. It runs the online responder service and a web proxy, and it receives and responds to the individual client requests for information about the status of a certificate. It's different than a CRL. Remember, CRLs are distributed periodically, and they contain all the information about certificates that have been revoked or suspended. An online responder receives and responds only to individual requests from clients for information about the status of a certificate. The online responder can process requests much more efficiently than using CRLs. Let's take a look at that. If we want to install the online responder role, it's relatively simple. We are going to go back into Manage Add Roles and Features. We're going to go next, next, next. Oh, I'm going to one too many next there. I'm going to expand the Active Directory Certificate Services, and we're going to select Online Responder and Add Features. And we're going to click Next, Next, and Install. And then once it is done, it is done. We simply need to maybe set some properties. Okay, so what we're going to do is we're going to click Configure. We're going to do Next. We're going to select the online responder. We do Next. We click Configure. And we're done with that. And we can click Close. Now, what you would need to do then is open up our certification authority. And we're going to select our CA. We're going to right click, we're going to go to Properties, and we're going to click on the Extensions tab. And we want to select an extension, and we're going to change to Authority Information Access. So we can see that there's a number of them here, right? We're going to click Add. And for the location, we're going to type in http:// the name of our server, which is lund-dc1, and another slash, and OCSP, just like that, and click OK. We can see it added. We would then also put a check mark to include in the AIA extension of issued certificates, and we put a check to include in the Online Certificate Status Protocol extension, and click OK. We're going to be prompted to restart. We say yes, and there it has restarted. Now let's go ahead and we're going to expand our server. We're going to right click on the templates and manage. And if we look down here, here is OCSP responder signing. Let's double click on that. Under the security tab, under authenticated users, we're going to allow them to enroll and auto enroll. And we click OK. We can now close our template console, and we're going to right click on certificate templates and say new certificate to issue. And we're going to scroll down, we're going to find that OCSP response signing, and we're going to click OK. So now we have that listed as one of our templates. We're going to go ahead and we're going to go to Tools, and you can see we now have Online Responder Management. I'm going to select that. I'm going to right click on Revocation Configuration and add Revocation Configuration. On the wizard, I'm going to click Next. In the name, I'm going to type in a datum CA Online Responder and click Next. On the location page, we're going to leave it as existing Enterprise CA, so we're going to click Next. And on the browse, we're going to click to browse for our certificate. And there it is. We're going to click OK. We're going to click Next. On the Select Signing Certificate, we're going to verify that both automatically selecting a signing certificate and auto enroll is checked off. It is. And then we're going to simply click Next. and finish. And that's going to be ready to roll. And we can close that responder page. Now, understand that CA roles are assigned and modified by members of local administrators, enterprise administrators, or domain administrators. On enterprise CAs, local administrators, enterprise administrators, and domain administrators are CA administrators by default. Because certificates and certificate authorities are important security tools used by a company, you may want to consider implementing what we call separation of duties to maintain the security of your PKI. So you may want to dedicate a CA administrator and exclude the domain administrator, the enterprise administrator, other roles to not be able to manage the CA. Keep in mind, those CA administrators, they've got the ability to assign all other CA roles and renew the CA certificate. They can configure policies, they can start and stop the service, they can define recovery agents, restrictions, delete one or more records. They have full access to your entire PKI infrastructure. Be very careful with who has access to that. As shown on your screen, you may wish to modify the CA permissions and understand what the role of the certificate manager, the backup operator, and the auditors are in conjunction with a CA and certificate services. Now, just like many of our other roles, we can back up our certificate authority. Sometimes you may not want to wait until a complete server backup occurs to back up the role. If you lose your CA, you could lose your entire PKI infrastructure. This might stop users from logging onto a VPN tunnel or accessing encrypted emails. So you need to know not only how to back up, but you need to know how to restore the CA so you can quickly bring up the CA in the event of a disaster. Keep in mind, a disaster is not always a catastrophic weather event. It could be a disaster in your facility. You can back up the entire server by backing up all the files in the system state using the Windows backup, but you can do it individually. So as you can see on your screen, you go to the certification authority, you right click your name of your CA, and all tasks backup CA. In the wizard, you could select to back up the private key and CA certificate as well as the certificate database and database log. And you specify a location. Would I specify a location on the current server? No. Specify a location that's somewhere, maybe not even in the same server room. A backup is only as good as its integrity. If you back up to the same server and that server is damaged, you can't restore your backup. If you back up to another server in that same server room and something catastrophic happens to the server room, you've lost your backup. Once you've performed your backup, understand that in the same way you can restore it. In this lesson, we learned what Active Directory Certificate Services is, that it's a server role and it gives us the ability to issue and manage digital certificates as part of our PKI. And PKI, it's a system consisting of hardware, software, policies, and procedures that are used to create, manage, distribute, use, store, as well as revoke digital certificates. Our CA binds a public key through a mathematical association with a private key. The private key is used to generate the public key. You cannot reverse, it's a one-way function. You cannot take the public key and use it to attempt to figure out what the private key is. A digital certificate is an electronic document, and it contains an identity, such as a user or an organization name, along with a corresponding public key. Because a digital certificate is used to prove a person's identity, it can also be used for authentication. This is how we use certificates with 802.1x. A certificate issued to a device allows it to authenticate through 802.1x for connecting to a Ethernet switch or wireless access point. Understand the concept of what a CRL is, a certificate revocation list, and how it differs from the online responder role that uses OCSP. And finally, understand the process of backing up your CA, where to back up your CA, and the fact that you just need to back up the private and public key for the CA and the certificate database. That's all that needs to be backed up. That includes everything, including the logs, of course. I hope you enjoyed lesson 11, and we'll pick this up in our next lesson.